Okay, we're going to go ahead and talk about lesson 10.3, which is experimental probability. Okay, experimental probability is very similar to just regular probability, but really the difference is experimental probability are events that have already happened. Like in the previous lesson we did, well, if I roll a dice, what's the probability that I'm going to roll a 1? Okay, well, it's 1 out of 6. Okay, I haven't actually done it yet. Okay, this is just what are the chances I'm going to do that. Okay, experimental probability are over events that have already kind of happened. Okay, so say I play a chess match with my son. We play 5 matches. Okay, I won 2 of them and he won 3. Okay, so the experimental probability that if we were to play again, what is the experimental probability that I will win? Well, let's see. I won. Okay, so I won 2 matches. My son won 3 matches. Okay, so we played a total of 5. Okay, so if we were to play again, what is the experimental probability that I would win? Okay, well, out of our first 5 games, I won 2 out of how many? 5. Okay, so the experimental probability that I will win our next match is 2 out of 5. Okay, the experimental probability that my son will win the next match is 3 out of 5. Okay, let's try a couple other things. There's a lot of looking into, they'll give you like a lot of tables. Like say I rolled the dice. This has already happened. Okay, I rolled the dice. Okay. Okay, so they'll have the outcome. Okay, so remember with the dice, my outcomes are I could roll the number 1, I could roll the number 2, I could roll the number 3, I could roll the number 4, I could roll the number 5, I could roll the number 6, okay? You know, with the dice, you figure, well, I have an equal chance of rolling each one of these, right? Because it's a dice, and I have a 1 out of 6 chance of rolling each one of those numbers. Well, say my dice is kind of, I don't know, messed up, okay? It's kind of heavier on one side or whatever. So say I roll it 20 times. Okay, I rolled the 1 3 times, a 2 6 times, a 3 once, a 4 5 times, a 5 2 times, and a 6. Well, let's see where I'm at. 3 times. Okay, so I've got the outcomes, and then this is the total times I rolled those. Okay, so I've got my little chart here. What is the experimental probability that if I were to roll that dice again, what is the experimental probability that I will roll a 1? Well, I rolled the 1 3 times out of how many? Well, you add them all up. It was 20, right? So the experimental probability that I will roll a 1 is a 3 out of 20. Okay? What is the experimental probability that I will roll a 3? Well, I rolled a 3 1 time, a 1 out of 20. All right. What's the experimental probability that I will roll an even number? Well, even 6 plus 5 plus 3. I've got a 14 out of 20, which remember when we're talking it's fraction, we've got to simplify. 7 out of 10. Okay? So they could ask you questions. They could give you this data, and they'll ask you what's the experimental probability, all these different things, and basically you do what we just did. But they could say, well, if we play this game, roll with the same dice, and say I win if an even number is rolled, and Bob wins if an odd number is rolled. Okay, who's more likely to win? Well, if you look, well, we did the experimental probability for even, which is 7 out of 10. So that looks pretty good for me. And then for Bob, the experimental probability for an odd number would be then basically the difference, 3 out of 10. Okay? So they would ask, well, okay, is this game fair? Well, looking at what's already happened, it seems a little one-sided, doesn't it? So then he would say, no, it's not fair because, you know, even numbers seem to be rolling more than odd numbers. Because the dice, we know there's something kind of weird with the dice. It seems to be favoring the even numbers. Okay, so that's kind of experimental probability. It's not totally different than regular probability, it's just looking at it in a different way. All right, so good luck.